hello everyone. We are back with one more concept that students have asked me to create a video on. This concept is about Armstrong numbers, right? And generally, we ask in programming what is an Armstrong number and how we will check whether a given number is an Armstrong number, right? So let us study this program, which actually tells you whether a number is an Armstrong number or not. But at the same time, we will try to first explain you what is an Armstrong number. Okay, so let us understand some basics about what is Armstrong number. So any number which is given to you, if that number, suppose the number is called 123, this number is 123, this is a three-digit number. This is a three-digit number. So, okay, so we need to check what is the digit value. So if it's a three-digit number, then what we will do, we will cube each each number that is the part of this complete number. One cube of 1, then cube of 2, and then cube of 3, right? So if we cube all these three and this sum up, we sum this up, and the sum, if this sum comes out to be 123, suppose, right? In this case it will not be in this case it will be 1 plus 8 plus 27, that is 36. So 36 is the sum. So 36 is not equal to 123. So 123 is not an Armstrong number. So we will check one more number. Suppose the number is called 153, right? Then what will happen? The number will be, because it's a three-digit number, it will be one cube plus 5 cube, cube of 5 plus cube of 3. So cube of 1 is 1, cube of 5 is 125, and cube of 3 is 27. Okay, when you sum them up, it will be 153. So what we saw, that this was a number given to us, and when we cube individual digits, when we do an individual cube of individual digits, what we get is, we got the number itself. So in this case 153 is a Armstrong number. So this is the basic concept of Armstrong number, that if you take out the digits, and if you take out the digits and then you cube, because it depends upon what you are doing. If you are cubing it out, or you are doing what is the power of the number, it depends upon the number of digits contained in the complete number, right? So if we take another example, suppose the example says, suppose the number can be 1 2 3 4, right? This is the number that is given to you. Then that case you will not cube it each digit. What you will do, because this number itself is a 4-digit number, this number itself is a 4-digit number. So in that case, if you want to check whether this is a Armstrong number or not, what you will do, you will raise this number to the power of 4, right? 2 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4, and the sum of all these things should come back to 1234. If it is, then it is an Armstrong number, otherwise this is not an Armstrong number. So the basic thing is, what the number of digits decide the power. Okay, the power is decided by the number of digits that is contained in this particular digit that is given to you. Okay, now for simplicity and for the concept building, we are considering that the number that we actually are taking, or we are asking from the user, is a three-digit number. So the first line says that we want to enter a number, and the number is of integer type, and here you can mention that you can enter only three-digit number. Okay, a three-digit number. So suppose the user enters 153. Okay, so your num will contain 153, right? The num will contain 153, and when you come to line number 2, what we are doing here is we are saving this num into another variable called original num. Okay, so your original num again has the value called 153. Okay, so we will see why we save this here. Okay, as of now understand that we are saving it in some variable. Now next we because we want to do a summation of 1 plus 5 plus 3, we want to have the sum of all these numbers, a cube of all these numbers. So we initialize a variable called sum and initialize it to 0. Initially this variable doesn't have any value, it's 0. Now coming to line number 6, it says that now we want to create the sum. For that we need, first time what we need the value of, in from 153 I need 3, then I need 5, and I need 1. And whenever I read this 3, I will try to cube it, and then I will read 5, I will again need to cube it. Then I will again need 1 and I need to cube it, and I have to stop that loop. So we initialize this num, we will initialize the loop. The condition that we have taken here is till this value of num is more than 0. Still this value is num is more than 0, we will continue the loop. Okay, now because this value of num is 153, it is more than the 0. So this first time this will come at the line number 7, that is remainder is equal to num modulus 10. So remainder num modulus 10, what will the value of the remainder? Remainder will be 153 modulus 10, right? That comes to be 3. So the value of the remainder is 3 now. Now if the value of remainder is 3, it will go to, because it's sequential coding, so it goes into the sum. The next line number 8, it says that here what will happen, it will be sum is equal to sum plus remainder raised to the power of this is 3. Okay, this is 3 raised to the power of 3 star 3, right? That means what will happen here is, here value of sum initially was 0. This sum was 0. So the first time the sum will be put at 0. Now I have the value of the remainder as 3. So it's 3 star 3. Okay. Then what will be the value? It come out to be 27. So 27 is the value that is assigned to sum. So if I create a table, here for easy, because if you understand this logic till now, I will create a table that will tell you everything in short, in concise. So there is something called remainder, there is something called sum. Okay, remainder and sum, and there is another thing called num. Okay, now the num initially was 153, remainder was 3, and the sum comes out to be 27. The next time what we'll have, we in this line, when we have sum, what we do, we change this remainder num by num division by floor by 10. Division by floor actually creates removes the last digit and keeps the new value of num as 15. Okay, now once these three things are done, what will happen, the system will again go up into while loop for checking whether the value of this condition becomes true or not. It goes up here. Now the value of num is 15, right? 15 is more than 0. Again it comes in, calculate the remainder. The remainder now is 5, right? The sum now is 27 was the initial value plus 5 raised to the power of 3, because this value was 3. So now it is 27 plus 125, that is 152. Okay, this is the new value of the sum, right? This is the new value of the sum. And then when it comes up here, it says num division by floor 10, so the value comes up to be 1, right? Now again goes up, the value of this num now becomes 1. 1 is more than 0, again true, comes down here, 1 modulus 10, the remainder becomes 1, right? Now sum value was 152 plus 1 star 3, that comes to be 153, right? and then we when we divide this 1 modular division by 4 10, the number comes 0, right? 0. So it will go up again. It says that 0 more than 0, the condition becomes false. At this time the control will reach line number 11. So the sum what we have is 153. Value of the num that we have is 0. Okay. Now understand, if we have used, instead of original num, if we have used something called num here, right? The sum value was 153, that was correct, and num value was 0, right? Num value is 0. Even if this sum is same as the original number, this if will never be true, right? In that case, you will always printed the original number is not an Armstrong number, even though the number is an Armstrong number, right? So to remove such cases, what we do, because we know that it will be reduced, the num is going to be reduced to 0 eventually. So we stored this num into an original num, and we never touch that original num in this logic, right? So original num was actually having this value called 153, right? Original num was having this value 153. So when say 153 is equal to 153, if though both values are same, the sum is equal to original number, we print the, and original number was 153, right, is an Armstrong number. So it will print the 153 is an Armstrong number, right? And in this, in other cases, when we have taken something else like 123 or 154, this sum will never be equal to the original number. Okay, so in that case the else part will be true, and you will get that the 154 number is not an Armstrong number, 123 is not an Armstrong number, like this. Okay. Now this is what about this was all about Armstrong numbers. Okay, so I hope you understand the basic what is Armstrong number, because any number which one raised to the power of the digits, and we sum up the some individual digits, we will get the same number. So it's known as Armstrong number, and the power depends upon the number of digits contained in that number itself. And this is the logic. If you find it if useful, do like and share that video, and if you want me to explain a new concept regarding this Armstrong number, that is, this was all about when you have when you actually know this is a 3-digit number or not, right? But sometime what will happen is you are going to enter a number and you don't know the number of digits, right? User may enter 4-digit number, user may enter 5-digit number, user may enter 7-digit number, and you will enter n-digit numbers, right? Now, because depending upon the number of digits he entered, you want to find whether it is an Armstrong number or not. Armstrong number can be a 4-digit number, Armstrong number can be a 6-digit number, 7-digit number. So this code need to be changed accordingly. So if you want me to explain that part also, do comment it out. I will create a special video for that particular part and explain you that part as well. So looking forward for your comments. Thank you very much. Have a nice day.